Okay, let's look at solving simultaneous equations. What are simultaneous equations? Okay, if we consider an equation 3x plus y equals 9, if we let x equal 2 and y equal 3, then 3x plus y would be equal to 9. It would work. Those values would satisfy this equation. But so would x equals 1 and y equals 6 satisfy the equation. If we think about another equation like 2x minus y equals 1, these two values of x equals 2 and y equals 3 would also satisfy this equation as well. Okay, but x equals 1 and y equals 6, whilst it satisfies this one, doesn't satisfy that one. Okay, but when we have two equations like 3x plus y equals 9 and 2x minus y equals 1 satisfied by a unique pairing of x equals something and y equals something, then we can say that these equations are simultaneous equations, and there's only one set of values of x and y that will fit both equations. Okay, so let's look at how to solve simultaneous equations. In other words, finding those values of x and y that satisfy both the equations. Okay, well, the first thing we need to do is we'll need to look at the two equations, x plus 2y equals 10 and 2x minus y equals 5. And the first thing we need to do is we have to make the number of x's or the number of y's the same. And the quick way of doing that is by when we have a situation where we've 1 beside the x here. The quick way of doing that is we can multiply every term here by 2, which is the coefficient of the x here. Okay, and we'll see what will be the result of that. But if we have those two equations, x plus 2y equals 10 and 2x minus y equals 5, if we look at the 2 and multiply everything up here by 2, we'll get 2x plus 4y is equal to 20. Okay, and we have our original lower equation here. The next thing we want to do is we want to be able to add these two sets, or add these terms. Okay, the x is the x's, the y is the y's, the numbers with the numbers. But we want, in adding them, we want to basically eliminate this elimination method, eliminate either the x or y's so that we can work with the other one. Okay, so if we multiply, the next step is to always multiply every term in the bottom equation by minus 1. If we need to make this positive and this negative, which is what we need to do, then you'll see that that will give us minus 2x, minus 1 by minus y plus y minus 5. Okay, now we can say 2x, now we'll add them, 2x minus 2x, that disappears, or as I always used to say, change the sign and add, which is what we've done, and we've 4y plus 1y plus y is 5y, and 20 minus 5 is 15. So if 5y equals 15, y is equal to 3. Now we're going to sub that value of y equals 3 into the top original equation. Okay, and if x plus 2y equals 10, then 2 times 3 is 6. X plus 6 equals 10. X is equal to 10 minus 6, x is equal to 4. So the values of y equals 1, y equals 3, sorry, and x equals 4 satisfy this equation, satisfy both equations, both the simultaneous equations. Now just to note, if both the x's or the y's have a coefficient greater than 1, then we can multiply each other equation by the coefficient of the other. So look at this, 2x minus 5y equals 9, 3x plus 2y equals 4. So these are different and neither of them are 1. So we can multiply the top by 3 and all the bottom terms by 2. So the top becomes 6x minus 15y equals 27. The bottom becomes 6x plus 4y equals 8. And you know, we've gone towards making these the same terms, which is what we want to do. Now we want to get rid of them, and we do that by multiplying all the terms in the lower line by minus 1, so we get this lovely minus here, and then we can say 6x minus 6x goodbye, and then we can add these terms, minus 15y minus 4y is minus 19y is equal to 27 minus 8 is minus 19, y is equal to 1. Sub y is equal to 1 back into any of the equations, either the top or the bottom, doesn't matter, and you'll find that x is equal to 7 here. Okay? Okay, so let's talk briefly about solving simultaneous equations graphically. Let's say we were given two equations, x plus y equals 1 and 2x minus y equals 4. And let's just take this first equation and just rewrite it in terms of y. So y is equal to 1 minus x here, okay? And if we have a range of input values for x and we put minus 4 into this equation here, 1 minus 4 is 1 plus 4, y would be equal to 5. And we could generate some y values for each x value. That would give us what we call ordered pairs, which we could plot on a graph. Okay, we could do the same for this equation here, just rewrite it in terms of y equals x plus something or whatever, and then we say if x equals minus 4, we find a value for y, and again we set up this bunch of ordered pairs, xy coordinates, which we plot, and we get a straight line like that. And you'd notice here that the lines intersect. The point that they intersect, that x comma y coordinate, is actually the solution of the simultaneous equations x plus y equals 1 and 2x minus y equals minus 4. Okay, it's the point. So basically we've solved, we've plotted the graphs, we found where they intersect, and in doing so we've solved the two simultaneous equations. Now we'll finish with a couple of real-life problems, okay, or using simultaneous equation solutions to solve problems, okay. So the sum of two numbers is 19, okay, x plus y is 19. When twice the second number is taken, minus sign, from 3 times the first, we get 22. Find the numbers, and basically we solve those simultaneous. Set them up. We've x and then 3x. We multiply all the top by 3, make them the same. Multiply by minus 1 all the terms here, and it'll change all the signs there. Cancel them out. Y equals 7, sub it back in, x equals 12. More interesting example here now. Tickets to a movie cost €8 or 10. If 300 tickets were sold and a total amount of money collected was 2640, how many of each type of ticket was sold? Okay, what we do is we let x equal the €8 tickets and y equal, the number of €8 tickets sold, and y equal the number of €10 tickets sold. So a number of €8 tickets and a number of €10 tickets were sold, and together that meant 300 tickets were sold. Okay, and the value of money of 8 times those number of tickets sold and 10 times, because €8 and €10, came to 2640. So now we've two equations. We've x with a coefficient of 8 here, hit the top one, multiply everything by 8, and then multiply everything here by minus 1 to give this line here. Goodbye to the x's, find the value of y, and then sub the value of it back into your top equation to find x equal 180. So therefore 180 €8 tickets were sold, 120 €10 tickets were sold.